Welcome to The Explainer. Today, we're diving into a project that's basically rewriting the rules for our super connected world. It's called CODECO, and it's trying to solve a huge problem we're all facing, a massive digital traffic jam. And this quote from the source material really just nails the problem. When it says low latency demands, what does that mean? Well, it's talking about things that need to happen instantly. Think about a self-driving car spotting a pedestrian, or a surgeon controlling a robot arm from miles away. There is absolutely zero room for lag. And that's the issue, right? From our smart cars and smart cities to online gaming and automated factories, the sheer amount of data we're creating it's overwhelming our networks. And this is creating these digital bottlenecks, slowing down the real-time responses that all these new technologies completely depend on. So, how in the world do we fix this? Well, in this explainer, we're going to first unpack CODECO's new rulebook. Then we'll see it in action, in our cities, our industries, and even in our own digital lives, before we zoom out to see the really big picture. All right, first up, let's get our heads around CODECO's solution. And you can really think of it as a completely new rulebook for how we handle computing. It all works on this principle called the edge-cloud continuum. Now, I know that might sound super technical, but stick with me. The idea is actually pretty simple. Instead of thinking that computing happens either right here on your device, that's the edge, or way out there in some huge data center, that's the cloud, this whole approach it breaks down those walls. It creates one single, seamless environment. Okay, so picture CODECO as a smart conductor for a digital orchestra. First, it listens. It figures out what an app needs. Does it need lightning speed, or does it need massive processing power? Then it looks across that whole edge cloud continuum and finds the perfect instrument for the job. It assigns the task. So maybe a quick calculation happens right at the edge, while a giant data analysis goes to the cloud. And this is the crucial part, it adapts on the fly if things change. Okay, that all sounds great in theory, but what does it actually look like in the real world? Let's take this concept to our streets and see how it's making our cities smarter and a whole lot safer. So, in Göttingen, Germany, the big challenge is managing traffic and keeping people safe. Now, instead of sending all the video and sensor data miles away to be analyzed, CODECO's solution is to do the processing right there, at the roadside, at the edge. And this means you get instant analysis of traffic patterns. And the goal here isn't just about speed, it's about being right. The pilot is aiming for over 75% accuracy, which is key to making sure the decisions the system makes are actually reliable and effective. Meanwhile, over in Barcelona, the focus is on protecting what they call vulnerable road users. So we're talking about pedestrians and cyclists. Here, CODECO is helping create a digital twin. It's like a live virtual model of the streets that tracks every car, every bike, every person to predict potential collisions before they even happen. And for this to actually save lives, it has to be unbelievably fast. I mean, just look at this timeline. From the moment something is detected to an alert popping up, the entire process has to take less than 20 milliseconds. That is literally faster than you can blink. And that kind of life-saving speed is only possible if you process the data right there at the edge. Okay, so we've seen it on our streets. Now let's shift gears and see how this same idea can help build a more efficient and, sustainable future for our industries. In Madrid, the problem is managing an electric grid that uses a lot of renewable energy, which, as you know, can be pretty unpredictable. So the Polytechnic University is using CODECO to create a decentralized smart grid that intelligently balances power coming from, say, solar panels, with the energy being used across all the different campus buildings. And here's the kicker, right? This has a direct impact on sustainability. This isn't just some tech for tech's sake project. The whole point is to achieve a real-world reduction in CO2 emissions of more than 10%. Now let's go inside a modern factory. A lot of them use these automated guided vehicles, or AGVs. But the problem is, these robots usually follow these super rigid preset paths, kind of like a train on a track. What CODECO is doing is giving these robot fleets flexible, intelligent navigation, which just boosts their efficiency and lets them be way more autonomous. And this just illustrates the shift perfectly. You're going from a rigid system that gets clogged up with bottlenecks to a smart, resilient one. The control is no longer stuck in one central brain. It's a decentralized intelligence that's shared across the whole fleet, letting the robots adapt to whatever is happening on the factory floor. All right, let's move on to our last set of examples. And these focus on how CODECO impacts our digital lives directly, everything from the movies we stream to the offices we work in. We've all been there, right? Staring at that buffering wheel on a video or dealing with a laggy online game. The problem is just getting that content from the server to your screen efficiently. Well, CODECO acts like a smart traffic cop for your data, analyzing all the possible routes to find the absolute fastest, most reliable path to you, which seriously improves your whole experience. And finally, let's talk about smart buildings. A lot of them are just a mess of separate, clunky apps for lights, heat, security, you name it. Instead of having to juggle all of that, CODECO steps in as a master controller, automatically deploying and managing these apps based on what's actually happening in the building. Now, what's really cool is how it works. CODECO can be triggered by different things. A topology change just means a change in the network, like someone installing a new smart light bulb. But it can also react to something as simple as room occupancy. So it detects people walking into a conference room and automatically fires up the presentation and climate control apps for that space. Pretty neat. So let's zoom all the way out and connect these dots. We've seen safer streets, greener grids, and way smarter digital experiences. What's the big takeaway from all this? Well, by treating the entire network, from the phone in your hand all the way to the most powerful cloud server, as one single flexible resource, this computing continuum pays off in big ways. We're talking about a fundamental reimagining of our digital infrastructure, making everything smarter, more responsive, and a lot more resilient for whatever the future throws at us. And that brings us to one last big thought. As our world becomes this incredibly complex, interconnected, digital orchestra, the question isn't if it needs a conductor anymore. It's who or what that conductor is going to be. Frameworks like CODECO aren't just technical projects. They're becoming the essential intelligent conductors for our future.